Hello everyone, myself Dhanasheras, Assistant Professor, CSE Department, Shriram Engineering College. Today we discuss about basic concept of graph theory, loops, multiple edges, simple graph, and bipartite graph. So graph theory is a branch of mathematics that studied points and lines. Points are called vertices, lines connecting them are called edges. But graph theory is not just about drawing dots and lines. It plays a huge role in real-life applications such as social networks like Facebook, search engine like Google, navigation system like Google Map, computer network and communication systems, artificial intelligence and data science. In this video tutorial, we will start from the basic concepts like what is a graph, types of graph, degree of graph, and path and cycles. Then we will gradually move to advanced topics such as Euler and Hamiltonian graph, trees and spanning tree, planar graph, graph coloring, and applications of graph theory. By the end of this video tutorial, you will not only understand the theory but also learn how to solve problems step by step in a simple and logical way. Next, a model. A vertex represented as a region, an edge or path between two regions. This diagram representing regions and bridges. This slide explains how real-world problems are converted into graph models. In left side diagram, that is called a real map representation to show land areas and bridges. This look like famous 7 bridge problems. In right side of the diagram, that is called graph representation. The map is simplified into vertex W, X, Y, Z, edges E1, E2, E3 up to E7. That is called representing bridges. This is a mathematical model. So notice that how the complicated map is reduced to points and lines. This abstraction helps us analyze the problems logically. Come to the next slide. What is a graph? In a normal definition, a graph is a mathematical structure used to model pairwise relationship. It consists of vertex or nodes representing objects, edges or links representing relationship between objects. The formal definition, a graph is officially defined by 3 things. What we call a triple, the vertex, the edges, and relationship. The vertex set denoted as V of G in this diagram or in this graph. So we have 4 vertices W, X, Y, Z. Now come to the next page. The edge set denoted as E of G. So these are the lines that connect the vertices. They show the relationship between the objects. In the diagram, the edges are labeled E1, E2, E3 up to E7. If vertices are people, edges would be things like a friendship or follower. The third one is the relationship. This is a word that tells us which is connecting to which vertex. For example, the relation tell us that edge E1 specifically connecting the vertex W and vertex X. So finally, the graph are used to social network, transportation systems, computer networks, and electrical circuits. The next move to loops and multiple edges. So what is a loop? A loop is an edge where both ends connect to exact same vertex. Look at the right side of the diagram labeled as a loop. In this graph, you can see the edge starting and ending at the same vertex. In real life example, a flight that start and end at same airport. And next one, what is multiple edges? Two vertices connected by more than one edges. Now look at the left side of the graph labeled multiple edges. So how vertex X and Z have two separate lines running between them. So this is a multiple edges. This one is called loop. The starting and ending vertex is same. In real world example, if vertex are cities, the multiple edges to represent two different highways or two different flight paths connecting to two cities. And next move to symbol graph. We have learned about vertices, edges, loops, and multiple edges in previous slide. Now let us talk about a very specific and important type of graph. It's called symbol graph. The definition of symbol graph that has two specific rules or restriction. Rule number one, there is no loops. The symbol graph cannot have any loops. And the second rule, the symbol graph cannot have multiple edges. So consider the following two graphs. This first graph is called not a symbol graph. This graph containing a self loop and multiple edges. So this graph is not a symbol graph. Consider this one is a symbol graph. This graph contains four vertices. There is a no loop and there is a no multiple edges. So this graph is called symbol graph. And next move to adjacency and neighbors. Now we need to talk about how the vertices and edges are related to each other. This is bring us to important terms adjacent and neighbors. The definition of adjacent: when two vertices are connected directly by the edge, we give them a special name is called adjacency. We say the two vertices are adjacent to each other. We also call them neighbors. So consider the following graph that containing four vertex A, B, C and D, and vertex A is directly connected to vertex B and vertex C. The vertex A is not directly connected to vertex D. So the vertex A and B are adjacent, and similarly the vertex A and C are adjacent. The vertex A and D are not adjacent. The reason is the vertex A is not directly connected to vertex D, is connected through the vertex B to D or the vertex C to D. This is a simple example for adjacency. Next, move to finite graph and null graph. We have covered the basic building blocks and the idea of simple graph. Now let us look at two more important categories called finite graph and null graph. The definition of finite graph means the limited number of vertices and edges. The edges and vertices are countable. That is called finite graph. Example, the graph contains 10 vertices and 15 edges. In real-time example, 10 cities to have 15 roads. And next, move to null graph. The definition of null graph, the graph having no vertex and no edges, that means empty. The, the vertex set and edge sets are empty. Next, move to complemented graph. Now we are going to explore a really interesting concept called complement of graph. The think of it is as an opposite or a mirror image of graph connections. So what is a complement graph? The complement of graph G, which is denoted as G dash. If two vertices are connected with in a original, they are not connected in the complemented graph. Similarly, if they are not connected in original graph, they are connected in complemented graph. And then next, the rules for building a or constructing the complemented graph. The first rule is the complemented graph is a simple graph. This means there is a no loops and no multiple edges. This is a very important rule. And second rule, the vertex set stays exactly the same in complement graph. That means vertex set of complement graph is equal to vertex set of complement original graph. And third rule, the edge set is all the pair of vertex that were not edges in original graph. That is represented as edge set of E dash equal to UV. Here UV means this vertex set where the UV is not belongs to edge set of original graph. The applications of complement graph is this complement is a powerful tool in a graph theory. Sometimes a problem that is hard to solve on original graph become easy to solve in complement graph. Next, move to